Problem 3, that's just simplification of algebraic expressions, and you have to eliminate any negative exponent. Okay, so this is basically just what you need to remember, that we have these laws, and we also have this one. And you also have these are obvious things, and that's sort of easy to prove, easy to remember. So let's do the first one. Well, let's just have, this is 1/9 squared and x to the -5/2 squared as well, and y to the 11/2 squared, and I have 3 to the power 4 times x to the power 4 and y to the -3 to the power 4. That equals so this would be well, okay, let's write it like that. So this 9 is 3 squared, so this would be 3 to the -2 squared. So this is, well, quite nice. This is x to the power -5, and this is y to the power 11. So this is 3 to the power 4, and that's just x to the power 4, and this is y to the -12. Okay, so let's put these together. So this is 3 to the -4 times 3 to the power 4. Get the x's as well. X to the power -5 times x to the power 4, and y to the 11th times y to the -12. Okay, so I lined them up. So previously I used this. It's very important not to forget about the constant, the number. While it's people just tend to, take the power of the symbols x and y, and they forget about the numbers. So that's a common mistake for some reasons. And we did this one as well, and now this is time to just add them up. So this would be 3 to the power 0 times x to the power -1 and y to the power -1 as well. Okay, well, 3 to the power 0, that's 1, and I have 1/x times 1/y. Well, it's just 1/x times y. Okay, this is how I eliminated the negative powers. I just put them into the denominator. Okay, the second one. So this was A. Now look at B. That may look even easier. So it's x to the power 4, y to the -7. So this will be y to the power 6, because 12 times 1/2, and while x to the power -4 as well. So I have x to the power 4 times x to the power -4, that x to the power 0, that's 1, and I have 6 plus negative 7. Oh, this is y to the negative 1. That's just 1 over y. So one question might be that, is it guaranteed that it's always this simple and nice? Well, yeah, there is no guarantee, but you know, this is an exam situation and someone has to mark your exam as well, and it's easier to see that, oh, did you get to the right solution? If it's simple, then, well, yeah, easy to see, then working backwards. Okay, so there is no guarantee. There is always this nice and simple, but, well, yeah, it is helpful for everyone. Again, the key point is not to forget to calculate the power of a constant, of a number as well. And I do recommend just remind yourself that these are the laws. It's like, you know, after many years I still write it there myself, because that's just a map of what I'm doing.